Hello student, I am Dr. Ajay Now I am continuing from the last class. Today I am going to discuss mole concept. Atoms and molecules are extremely small in size and in size it is very small, but their numbers is large. For that purpose, mole concept has importance. Just as we denote 1 dozen for 12 items, a score for 20 items, gross for 144 items. Like that way, mole is considered for large number of atoms or molecules or ions or any particles. Mole, we can define the mole as or you can tell 1 mole is the amount of a substance that contains as many particles or entities as there are atoms in exactly 12 gram of the 12C isotopes. 12C isotopes means 12 gram of carbon. How many atoms it has? That number is important. 12 gram carbon of 12C isotopes 12C. How many atoms it has? That is called 1 mole. Again I am repeating, 1 mole means 12 gram carbon. 12 gram carbon, how many atoms it has? Correct? And how it is calculated, that I am going to tell you. That is also important for you. In order to determine this number precisely for mass of a carbon 12 atom was determined by an instrument called a mass spectrometer and found to be equal to 1.992648 into 10 to the power 23 minus 23 gram. By use of mass spectrometer, mass of 1 atom of carbon was determined and it was found to be 1.992648 into 10 to the power minus 23 gram. Actually, mass spectrometer is used to determine very less amount. It can be measured. Then by mass spectrometer, one weight of 1 atom of carbon was determined and it was found, I told you, 1.992648 into 10 to the power minus 23 gram. This is the mass of 1 atom. It's a mass of 1 atom. Now it is very easy to calculate how many atoms are there in 12 gram of carbon. Very easy. Then here that 1.992648 into 10 to the power minus 23 gram equal to 1 atom. Then 1 for 1 gram, for 1 what will be there? 1 divided by 1.992648 into 10 to the power minus 23. Then for 12 gram, how much? Just simply have to multiply. Means 1 divided by 1.992648 into 10 to the power minus 23 and upside into 12. That is the actually after simplification it will come 6.0221367 into 10 to the power 23 atoms per mole. This is a very simple calculation. That starting point is that 1.992648 into 10 to the power minus 23 gram equal to 1 atom of carbon. Then for 1, then for 12. Simple calculation. Then after that its value will come 6.0221367 into 10 to the power 23 atoms per mole. These atoms per mole. This number is called actually Avogadro constant or Avogadro number. Then this Avogadro number is denoted by capital N and down A, capital A, Na. Na means Avogadro constant or Avogadro number. This number is very, very important. This actually mole. This number is called 1 mole. This always you keep in mind. This number, this is a big number, huge number. This number is called 1 mole. This is a very, very important concept. That Avogadro number is equal to 1 mole. Like this way, other concept is also there. Mole concept, that's why name has given mole concept. Then what are the other concept? First I told you Avogadro number is equal to 1 mole. And second concept is that molecular mass is equal to 1 mole. Already I told what is the molecular mass. Molecular mass is equal to 1 mole. And third concept is atomic mass is equal to 1 mole. If you are talking about the atom of metals generally, then one mass of atomic mass or atomic weight is equal to 1 mole. This is the third concept. Now next concept is that this in terms of volume, 22.4 liter at STP, at a standard temperature and pressure, 22.4 liter at STP, that is also equal to 1 mole. 22.4 liter also you can tell 22,400 ml at STP is equal to 1 mole. Then I have told you about mole in terms of number, in terms of weight, and in terms of volume. Then mole, actually you can tell mole correlates number, volume and weight. If you are knowing the number of moles, then easily you can know what is its quantity, means weight, how many atoms or molecules are there, or what is its volume. All three you can know by knowledge of mole. That's why mole concept has very important, or is very important. Other things I am telling you, again I am telling you about the mole. Mole means, mole tells about the number. Moles tells about the volume. Mole tells about the weight. It correlates all three things. And here mole means anything, as suppose Avogadro number, anything in this number, anything, maybe pen, pencil, coin, book, anything in this number, maybe atom, maybe molecule, maybe ions, maybe particles, any particles, anything in this number, Avogadro number, that is called 1 mole. This is very important. And other things I am telling you, that is the that relates with molarity. Molarity, number of moles of solute. Number of moles of solute, that is equal to molarity into volume of solution in liter. In liter. This is again very important relation I am talking about. Number of moles of solute is equal to molarity into volume of solution in liter. Here I want to clarify. Solute, you know that in solution, solute plus solvent is equal to solution. Actually, I will tell you details at the right place, but here I am telling you just a brief idea that solute plus solvent, that is equal to solution. As for example, solute like salt, NaCl. If you will add NaCl, means salt, in water, then water is solvent and NaCl is solute. If you will mix it, solution will be formed. If sugar you are adding in water, then sugar is salt and water is solvent. Just here you keep in mind whose quantity is more, that is called solvent. If salt is less and water is more, then water is solvent, and NaCl is solute. If sugar is less, water is more, then water is solvent and sugar is solute. Now I want to tell you about the molarity. Molarity, RITY. Other similar terms are there, I will tell you later on. Then molarity means number of moles dissolved per liter of the solution. Number of moles dissolved per liter of solution. In 1 liter of solution, how many moles are dissolved? That is called molarity. Hence, relation now it is clear. Number of moles of solute is equal to molarity into volume of solution in liter. Liter, I am emphasizing term liter. Now, same way, one more relation is there, two more is there. Then now in terms of millimoles, number of millimoles, that is equal to molarity into volume in milliliter. Very simple. Earlier I told you molarity into volume of solution in liter. In liter, that was the number of solute. Here, number of millimoles equal to molarity into volume in milliliter. Or simply you can tell millimole divided by 1000 that is equal to moles. Again, important relation. This is also important relation. Millimoles divided by 1000 that is equal to moles. Now, last concept I am telling you. For a compound capital Mx Ny, suppose compound is like this, capital M and down X and capital N down Y. As for example, C2H6, then Mx means C2, H6 means Ny. In general way we are telling Mx Ny. X is down, Mx, X is down, and Ny, Y is down. Just like C2H6, C2H6. Here 2 means X and Y means 6. C2H6. This is called Mx Ny. Then this is in generally in compound or in molecules. Number, I told you H2O. Then for the X 2 and for the oxygen 1. H2O. CH4. Carbon is 1, means X is 1 and Y is 4. CH4. Then CH4 means C is 1, only 1 is there, then X is equal to 1 and Y is equal to 4. That's why in a common way, generally it is denoted by Mx Ny. Then here relation is that X moles of N is equal to Y moles of M. X moles of N is equal to Y moles of M. This is very, very helpful in solving tough numericals. Okay. Another things I want to tell you, in solving the numericals, balanced chemical equation is necessary. Actually, mole concept numericals will be based on balanced chemical equation. Actually, I will give you separate, I will just easy to toughest problem I will solve you, and I will give you in the video in a separate sheet. Today theoretical things I am discussing. Then I was telling you that in solving the numericals, balanced chemical equation is necessary. Coefficient represents relative number of molecules or moles of the reactants and products. This again is very important. Again you listen carefully. Coefficient represents relative number of molecules or moles of the reactant and product. As for example, potassium chlorate 2KClO3. Suppose reaction is like that, 2KClO3, this is found in solid. You can write in bracket S also. S means solid. Always if you are writing chemical balanced equation, then you must write phase, whether it is a solid phase or liquid phase or vapor phase. If it is a solid phase, then you write a small s in bracket. If it is a liquid phase, then you write a small l in bracket. If it is a gaseous phase, then you write a small g in the bracket. Make habit. Okay. Then here, suppose balanced equation is like this. 2KClO3, so it is solid. It gives 2KCl, potassium chloride. Potassium chloride is again solid. You write solid in bracket. Plus 3O2. O2 is gas. Hence in bracket you write gas G. Then this is the actually balanced equation. 2KCl3 that gives, that is equal to, or you can write arrow sign, it will give you 2KCl plus 3O2. This is the balanced equation. Here 2KCl3 is giving. You are taking 2KCl3 and you are getting 2KCl and 3O2. Then 2KCl3 is called reactant. And what you are getting, that is called products. Here 2KCl and 3O2 is product, 2KCl and 3O2. Then now by 2KCl3, what does 2 means? Then 2 means 2 molecules. 2KCl3, this 2 means 2 molecules of potassium chlorate, or 2N molecules, or second way you can tell 2N, capital N, Avogadro number, 2N molecules or 2 moles. It tells 3 things. 2KCl3 means it is telling 3 things. First, it represents 2 molecules. Second, it represents 2N molecules. Avogadro number, 2N molecules. And third thing, 2 moles. Like that way, product side also same way. 2KCl means 2 molecules of KCl, or 2N molecules of KCl, or 2 moles of KCl. Like that way, 3O2 means 3 molecules of oxygen, or 3N molecules of oxygen, or 3 moles. 3 things it is telling. Correct? This is the very, very important concept I have told you. And for any other balanced equation, means coefficient tells same meaning. Any other reaction, balanced reaction is there, then it will tell same thing, same concept will be applied for other balanced equation also. Now I want to tell you about percentage composition. What is actually percentage composition? I want to give you idea. Suppose you are talking about H2O, water molecule, H2O. Then here H2O, this is the molecule. Then its molecular mass easily you can calculate. H2O means 1 into 2. 1 into 2 because 2 hydrogen is there. Roughly 1.008 we are taking as a 1 only. Then H2O. Then 1 into 2 plus 16. Oxygen atomic mass is 16. Then it became 2 plus 16, 18. 18 is the molecular mass. Now, if you want to know what is the percentage of hydrogen, in water, then easily you can calculate 2 divided by 18. 2 divided by 18 means in 18 gram of water, 2 gram hydrogen is there. Then for 1 gram, 2 by 18. Then for 100 gram, 2 by 18 and upside 100. Then you will get the percentage of hydrogen. 2 into 100 divided by 18. Means as a formula, you can tell mass percentage of an element is equal to mass of that element in the compound into 100 divided by molar mass of the compound. This is the formula you can use for all element in the compound, every element in the compound. Now I have given example for water, H2O. Then in this H2O, what is the percentage of oxygen? Then same way you can write that out of in 18 gram water, 16 gram oxygen is there. H2O, 2 plus 16. 18 was there and 16 gram oxygen. Then 18 gram water contains 16 gram oxygen. Then 1 gram water will contain 16 by 18. Then for 100 means 16 into 100 divided by 18. Whatever will come, that is the percentage of oxygen. Like that way you can calculate for any element, percentage of element or mass percentage of any element in the given compound. By following this method you can calculate. Okay, now just I am telling you that if you will calculate mole mass of you can say hydrogen, percent of hydrogen, mass percent of hydrogen, then its value will come 11%, 11.18 means 2 into 1 divided by 18 and upside 100. After solving it will come 11.18. Similarly for oxygen it will come 16 divided by 18 upside 100, it will come 88.79. Okay, then this I told example of water molecules. In that water molecules, what is the percentage of hydrogen and oxygen. Similarly, one more example I want to give you, that is the C2H5OH, ethyl alcohol. Ethyl alcohol. It looks big, but same way you have to follow. Here carbon is 2, C2H5OH. Then carbon is 2, hydrogen is 6, C5OH. Then C5OH, 5 plus 1, 6 hydrogen is there, 1 oxygen is there. Then just you follow same way. C2H5OH, calculate the molecular mass, 2 into 12 plus 6 into 1 plus 16. Exactly you will keep all the value. It will give you 46.068 gram. 2 into 12.01 plus 6 into 1.008 plus 16. Add all, it will come 46.068 gram. This is the molecular mass of ethyl alcohol. Now here this is the molecular mass. Now follow same way. For carbon percentage we want to know carbon percentage in ethyl alcohol. Then 2 into 12, that is a 24, or exactly 2 into 12.01. Then 24.02 divided by 46.068 upside 100. Then its percentage will come 52.14%. Same way mass percent of hydrogen. Then here 6 hydrogen is there. Then 6 into 1, 6, or exactly 6.048 gram. Then 6.048 gram divided by 46.068 into 100, upside 100. It will come 13.13%. Similarly, mass percentage of oxygen, you can calculate same way, 16 divided by 46.068 gram into 100, upside 100. Then percentage will come 34.73%. If you will add all, carbon percentage, hydrogen percentage, oxygen percentage, it will become 100%. In all cases, in water also what we have calculated, hydrogen percentage and oxygen percentage, if you will add both, it will come 100%. Today I am stopping only here. Next class I will come to the next topic, and if possible I will give you numericals based on mole concept. Okay, thank you.